So, as I mentioned earlier, what we're going to be talking about today is using Imply, which is a big data analytics platform built on top of Apache Druid to try to prevent and detect fraud. So first we need to understand how fraud works. And it turns out that there's two primary profiles for our customers who are trying to detect fraud. One is card issuers, and the other one is payment processors. So card issuers are likely banks such as DBS Bank, but there's also a lot of fintech startups who are in the card issuer group, such as Ibotta. And they're hit with penalties when fraudulent actors open too many false accounts. In 2015, credit card and debit card fraud caused card issuers to lose $21.84 billion. Payment processors, on the other hand, such as Square and PayPal, deal with transfers of money and get chargebacks against their revenue due to fraudulent purchases. Back in 2015, PayPal was hit with a $7.7 million fine by the US Treasury Department on just $44,000 of transactions. The US government prohibits companies from doing business with certain people or groups, and PayPal was accused of failing to screen its transactions properly. Imagine if PayPal's fraud operations analysts had been able to prevent those transactions and save their employer millions of dollars in fines. Negating this risks requires your internal fraud operations department to quickly analyze trillions of data points in under a second, and then get answers to follow-up questions just as fast. In today's demo, I will explain how Imply helps you overcome three main challenges. One is technology challenges. How technology birthed in the early days of fraud operations is ill-suited for the modern business. Two is operations challenges. How the vastness and complexity of data needs to be reframed when we think about digital threats. And three is scaling challenges. How to crystallize data experts analysis in a consumable and scalable means for low-cost teams. We've broken down fraud operations workflow into its atomic components, and we'll be demonstrating how a fraud operations analyst can use Imply to quickly analyze potential fraud and prevent it. The fraud ops workflow begins with the generation of some activity, be this an account creation or the completion of a transaction. Data about this activity is passed to a rule engine or machine learning algorithm, which then assigns some probability of fraud to this activity. If the probability of fraud is below a certain threshold, the activity is automatically approved. If there is a higher probability of fraud, data about the activity is passed to a fraud operations analyst who can use Imply to figure out whether the activity is fraudulent. But rather than speak about this in hypotheticals, let's dive into a concrete example of how a fraud analyst might use Imply. I'm playing the role of a fraud ops support technician. My old analytical system was built up organically over time from audit logs. A system like Elasticsearch or Splunk is used to manage and search across all those files. While those tools are great for log capture and search, they weren't built to perform high-speed analytics at scale. In fact, many of these home-built solutions weren't built to scale at all. Furthermore, it feels cumbersome or impossible to ask follow-up questions from the data, which is critically important when I'm trying to analyze from multiple angles. This is the technology challenge organizations face. Thankfully, my company just implemented Imply, which solves these challenges by being a purpose-built to provide the fastest self-service analytics at any scale. It's full complement of services that provides intuitive data access, cluster management, security, and performance optimization. Let's say that I just received a notification from my fraud operations detection engine, indicating that a particular account has been attempting a large number of suspicious transactions. I can open the review case link and immediately be transported to a screen which has all of the information that I need to start analyzing this case. Integration into Imply's interactive data visualization UI, called Pivot, is as easy as opening this deep link, which applies all necessary filters and takes me directly to the suspicious account. This dashboard gives me contextual information about the fraudulent activity, and my old tooling rarely went beyond this report. Fraud ops technicians like myself need to look at data from all sides, starting from the specific transaction and looking wide to analyze trends, or in reverse, starting broad and narrowing in. And we need an intuitive interface to do this. Like Tom Cruise in Minority Report using his fancy gloves to spin the information on screen to prevent the next crime, I want to spin my data just as fast to do the same. I'll skip the fancy gloves for now. I'm looking at many sources of information about this account and this transaction on this interactive dashboard. As easy as Tom did to his screen, Imply makes data analysis completely intuitive, which explains why it's been rapidly adopted across teams at PayPal, DBS Bank, and the New York Stock Exchange. I'm looking for patterns that indicate fraudulent activity, such as suddenly sending large sums of money at off hours to strange destinations. In fact, if I highlight just the morning transactions, I can see that none of them are fraudulent. Conversely, if I look at just the afternoon transactions, I can see that they were all fraudulent. So let's investigate why these afternoon transactions were flagged. This is Imply's drill down interface. It's the most efficient means to do interactive analysis and have a conversation with your data. While not three-dimensional on the screen, like in Minority Report, its dimensional analysis is infinite. For starters, let's determine where this money is going by simply dragging the transaction country over to the show bar. And now I know all fraudulent transactions are being sent from this American account to Russian banks, while the non-fraudulent transactions are going to American banks. That's an interesting correlation. I want to dig deeper and understand the relationship between the value of fraudulent transactions and country. First, I'm going to remove the account ID filter to look at data across all accounts. That's interesting. When I zoom out like this, it looks like Russia is the most common source for fraudulent transactions, even though the US, Sweden, and the Philippines are the most common non-fraudulent countries. This is interesting too. It looks like all of the transactions marked as fraudulent are coming from Eastern European, former Soviet bloc countries, like Belarus and Ukraine. To further drill down on this data, let's test this hypothesis. We can filter down to only look at fraudulent transactions. From here, we can change the type of visualization to a tree map and change the variable being measured from the number of transactions to the transacted or fraudulent amount. And voila, now we can see the proportions of each country's fraudulent activity. This seems to further validate our previous hypothesis that most of our fraud is coming from Eastern Bloc countries. This seems like useful information to surface to the people in charge of creating the rules engine. Now, let's go back to our particular account and understand how we can incorporate this new information into our analysis of these transactions. Let's look only into the Russian transactions and then select only these particular banks. And now we know that these banks correspond to fraudulent transactions for this particular account ID. But what about in general? Are these banks commonly used by fraudsters to steal money from American accounts? Looking from the top down across all transactions from these banks, it seems that they primarily process fraudulent activity across all accounts. I can use this information to preemptively flag these routing numbers and prevent future risk to my business. In this hypothetical scenario, a fraud operations analyst was able to quickly spin the data around without re-architecting their data lake or writing new complex queries to handle this new workflow. This highlights the operational challenges that these support teams face on a daily basis and the power of Imply to solve these challenges. This brings us to the final challenge that fraud operations analysts face. They're not highly technical, and they're also not financial experts. They need a solution that is easy to learn, highly extensible, and gives results fast. They need to scale. We see two challenges facing organizations of various sizes. For smaller orgs or for startup companies, the fraud operations experts are actually the founders or senior level engineers who are now responsible for protecting their budding company. As they grow, they are challenged to impart their deep technical wisdom to a rapidly scaling team. They visualize the data. They know it, while others only see SQL statements and log files. For larger orgs, we see rapid onboarding and productivity as a driving force behind adopting a new platform. As said before, home-built solutions are very niche and limit the ability for new, large teams to work effectively and efficiently. By going with a vendor-provided platform, you not only save yourselves hundreds or even thousands of hours of development work, but also are guaranteed to have access to a best-of-breed interface, which is both intuitive for a fraud analyst and flexible to give them access to the data they need. Recapping, Imply is a full-stack analytics solution, purpose-built to provide the most performant self-service analytics at any scale. We address the three major challenges facing fraud operations teams today across organizations of all sizes: technical challenges, operational challenges, and scaling challenges. All right, thanks for coming to today's presentation. If you have any questions, please feel free to surface them in the chat or reach out to me either via email. My email is danny.lebzon@imply.io, or via LinkedIn, where you can find me at danny.lebzon. Thanks for taking the time. If you have any questions, I'll be happy to answer them now.